In this video, we're going to talk about how to create subdivision surfaces and go over the basic fundamental principles that we need to know in order to ensure that our mesh is smoothed correctly when we hit the tab key. As you can see here from my viewport, I have this really cool model of a rhinoceros. And if you look very carefully, I think if you look specifically at the head of the rhinoceros, you can see that there's a ton of polygons, and it roughly looks like a rhinoceros. It's pretty basic, but it's pretty faceted. There's a lot of hard edges and some sharp corners. Now, there's some pretty good detail in here. We can see some folds and creases along where the horn is, where the eyebrow and the eyelids are. There's some really neat detail in here, but we want to smooth all this out. We want the computer to go in and figure out how to round all the edges intelligently, but still retain the overall basic shape. Now, we can do this really intelligently using the subdivision surfaces toggle. To apply or to toggle our mesh from a polygonal cage, which is what it's currently in, into a subdivision surface, we have to hit the tab key on the keyboard, like that. The moment we hit the tab key, we toggle our polygonal cage into a sub-D surface, and you can immediately see the gorgeous effects of applying the subdivision surfaces toggle to our mesh. Now, all of our nice little organic curves are smoothed out. We don't see those faceted edges, and a lot of the really important details like these folds in here and along the neck really come to the surface and shine. You want to use subdivision surfaces for organic models because it smooths out all the hard surface edges and gives the illusion of perfectly smooth and curved surfaces. At the core, though, we still have the exact same polygonal cage. If we hit tab again, we can see that the model itself is still basically constructed off of the exact same polygons that we originally had. So the tab key is a toggle, so we can go back and forth from our polygonal cage to our subdivision surface just by hitting the tab key. Okay. Now this is an illusion. We're smoothing out the entire, we're creating the perception that we are smoothing out the entire surface, but in actuality, the computer is just kind of averaging some normals here and some faces to get the effect of our subdivision surface. Okay. Now, most importantly, if we hit tab and go back to our polygonal cage, you can see that the OpenGL meter here is running or is solving 9,012 polygons. So 9,012 polygons. If we hit tab, though, we're now to a big hit. Since we're creating the illusion of a perfectly smooth surface, we're now being hit with 145,000 polygons. So subdivision surfaces can take a little bit longer to render, but creating the initial shape, creating the base model for our rhinoceros is relatively easy using our polygonal tool set. So let me get rid of this guy, and I want to take you in, and we're going to start building some sub-D surfaces. I mentioned before that we're going to be using our traditional tool set to create our subdivision surfaces. It all starts with a polygonal cage. I want to turn on my work plane real fast just so I can see where I am in my three-dimensional universe. And I'm going to create a cylinder. And on this cylinder, I'm going to create it with 12 sides. I'm going to click once in my 3D viewport to lay down my initial starting point, move my cursor away from my tool handles, and I'm going to left click and drag the control key to draw out a perfect circle. There it is. That's looking pretty good. And let's give it a little bit of a height to create just a very basic cylinder. That's looking really good. Now, one of the advantages, as I mentioned with sub-D surfaces, is that it's going to smooth out the entire surface. I only have 12 sides on this polygon, or on this cylinder, so there's not a whole lot of resolution. Now, up close, we can very easily see the hard edges and the facets that are being created from the polygons. Well, I don't want that. I want it to be perfectly circular. We can do that by toggling this mesh into a subdivision surface. Now, remember our golden rule in Modo, and that's whatever selected is going to get edited. So if nothing in our scene is selected when we hit the tab key, all of the polygons on this mesh item are going to get transferred or translated into a subdivision surface. If we select a series of polygons like that guy and hit the tab key, only that polygon is going to get changed into a sub-D. So I'm going to select everything, hit the tab key, and whoa, that's not exactly what I thought I was going to get. My mesh, my cylinder, my beautiful cylinder completely collapsed. Well, they collapsed because it's trying to smooth out all of these polygons and and it's analyzing the location of these big n-gons here at the bottom, and it's creating some weird results, okay? So think of a sub-D surface as trying to take this edge and this polygon here, so that guy and that guy, and smooth out the difference between the two and create a nice smooth transition between these two planes. Now, I clearly don't want that, okay, because that looks kind of like a squashed pumpkin. What I would like to see, or what we can build with our subdivision tools, is a shape that looks almost perfectly circular, but we need some extra edges in there. Sub-Ds require some extra love. It requires some extra edge loops running around very specific places on our mesh to create hard edges and sharp corners. I'm going to hit Tab again to go back to my original cylinder, and I'll show you what we need. Wherever we have a transition from one plane of axis, so we got this guy here and this guy here, we need some edges running along the top of this loop and the top of this polygon to preserve the corner. I'll show you what I mean. I'm going to select both of those polygons there and go to my Mesh Edit tools and run Loop Slice. So Mesh Edit, Loop Slice. I'm going to leave my count to 1 with the mode of free, and then left click in the viewport to apply the tool. And I'm just left clicking and dragging here to interactively place my new edge loop, and I'm going to place it kind of close to the top. It doesn't need to be all the way at the top like that, but just somewhere kind of right around in here. Wherever we want to have a sharp edge on our subdivision surfaces, we need an extra edge loop running below the original and then above the original. Now, on top here, we have a polygon, a big n-gon. So, and a big circular n-gon is on top of that. So we're going to use the bevel tool, the polygonal bevel tool, and give it a little bit of an inset to create that extra row. Okay, so if we analyze this transition here, this edge, these polygons right in here, we're going from one plane to this plane. The sub-D engine wants to smooth out those two planes and kind of round out that corner for us. Because we have two edge loops, this one and this one, above and below the original corner, the sub-D engine is going to hold that edge, and it's going to be kind of sharp when we hit the tab key. Let's check it out. Bam, check it out. On the bottom, where we didn't place those edges, you can see that it's completely collapsing and looking pretty poor. But at the top here, this is looking pretty good. We're getting the illusion of a very simple beveled edge, but at the same time, we're also maintaining the structure of our original cylinder. So let's do the exact same thing that we did down here in the bottom with these two edge loops. We're going to do the exact same thing that we did on top on the bottom. So first things first, going to select some polygons, just these two guys right here, and run Loop Slice again. A count of 1, mode of free, and I'm going to left click and drag in my viewport until I place that bottom edge loop right down there. Okay, awesome. Now we're also going to grab this bottom polygon, and we're just going to bevel him in just a little bit to get that extra row of edges right around the corner there. So remember our rule of sub-D. If we want to have a hard edge in sub-D mode, we have to have two extra edge loops, one above the original edge and one below the original edge, like that. Okay, there it is. Let's zoom out a little bit and see what we got. Hit the tab key. There it is. Now our cylinder is maintaining and retaining its shape when we hit the sub-D mode key, the tab key. Okay. Now, also, there's one other thing that I want you to look at, and this is kind of one of the really cool things about sub-Ds, especially when working with cylindrical objects. We made our initial cylinder with 12 sides. It's pretty fascinating. You can see a lot of hard edges as we go around. Because we are flipping and converting this polygonal cage into a sub-D, check it out. It now looks perfectly circular. All of those hard edges have been smoothed out, and now we're creating the illusion of a perfectly circular, high-resolution cylinder, which is kind of cool. So the advantage of using sub-Ds is that we can use our traditional modeling tools, and by creating very simple shapes and then converting them into sub-Ds, we're able to create the illusion of really high-resolution polygons, or high-resolution meshes, which is pretty neat. I love it. It's pretty cool. Okay, let me show you another example. I'm going to get rid of my cylinder here, and I'm going to create a very simple, just unit primitive. Okay, just a simple cube. If I hit the tab key now, you're going to see that my cube collapses. The subdivision surface engine is trying to smooth out that shape whenever I hit the tab key. So we need some extra edges in here to hold up the corners, to retain to retain the original shape. Now we could use loop slice. Let me show you what that looks like. We're just going to grab those 2 polygons there, go mesh edit, loop slice. Now we could absolutely do it with a count of 1 on a mode of free, but we know that we're going to need an edge at the top and an edge at the bottom. So we have a couple options. We could increase the count to 2 and also keep the mode of free, and then interactively place the loops with the little widget, kind of like that. That's one way. That totally works. But I'm a little bit of a control freak. I'm going to hit undo. And I want to have the new edge at the top and the new edge at the bottom be exactly the same equidistance from their respective edges. So in loop slice, I'm going to change my mode to symmetry. And when I left click and drag now, notice that I'm affecting both loops at the exact same time, and I can place them in the exact same spot on the top and on the bottom. I like that. That's pretty cool. So that's one way of very quickly going in and adding some extra loops. Now, let's hit the tab key and see what we get. Okay, so still not a cube, but it looks kind of like a cylinder now. We ran some loops going around our mesh this way. Okay, but we need to go in 2 other directions. We also need to go this way. Okay, so let's run loop slice again. Count of 2, mode of symmetry. There it is. So the tab key, and we're getting there. We have one more axis that we need to edit. So we want this way. We want this way with our loops. Now we need to go this way along all 3 axes. Run the loop slice again. And there it is when we hit the tab key. The tab key toggles it back and forth between SubD and your polygonal cage. All right, I want to delete this guy. And we're going to make one new cube because this is going to show you, I want to show you another way of doing the exact same thing. Maybe you don't want to use loop slice. Remember our principle. We have to have a row of edges above up here and below down here of our original edge here in the center. So we need a new edge loop below it and above the original. So we need 2 extra ones. We could very easily do this just using the edge bevel tool. Okay, so I've selected all the edges that run along the top of our cube, kind of like that. That's looking pretty good. And this time, I'm going to run the edge bevel tool with a count around this level of 2. Actually, I take that back. I'm going to put my round level back to 1. Back to 1. There we go. Because with a round level 1, check out what's happening. Here's the location of the original edge, this guy here in the middle, and then we're adding one below and one above, exactly what we need to ensure that the SubD engine doesn't collapse this part of the geometry. If we hit tab, hey look, it's trying its hardest to shore up that top edge, but we need some more. So we need to bevel all of the edges in this polygon, this cube, like so. Let's bevel them again. Round level of 1, and let's give a little bit of an edge bevel. And the reason I wanted you to do all of them at once is to ensure that the corners got the proper miters. If you look very carefully here, the polygons that make up the corners are all quad polygons. That has 4 sides, 4, this one over here has 4, this one has 4, this one has 4s. So that's good, that's what we want. Doing all the edges in the cube at the same time just makes the entire modeling process just a little bit easier, so I like that. I'm going to drop the tool, deselect my edges, and hit the tab key. And you can see that the SubD engine is now holding the shape on our cube. And it's doing so because we placed these extra edges in here, okay, all the way around our mesh. Those edges, those guys right here, the ones that I'm selecting, are responsible for shoring up our edges and creating that nice hard surface transition when in SubD mode. Okay, that's looking pretty cool. I love working in SubD modes. So there's a couple little tricks that we have to remember. It's all about adding edge loops in very specific places. Let me show you one other example. I'm going to create a very simple cylinder here. And we're going to create kind of a cool shape with this. I'm just going to bevel this top one out. And we're just going to make kind of like a little bit of a wood turning profile thing here. Just very simple shape like this. Okay. Now, if we were to convert this into SubD mode by hitting tab, This is what we get. Now that looks cool, but I want all of the edges along this profile to be nice and sharp. So this corner in here on the top, I want that to be sharp. This inside edge to be nice and rounded. This guy, and this guy. Now I showed you the loop slice tool when working with cylinders, but here's the thing. We can also use the edge bevel with cylinder. We can also use edge bevel with the cylinders as well. Excuse me. So if we were to fire off edge bevel now and just do a little left click and drag with a round level of 1, we've gone in. We've added some edge loops now, and when we hit tab, voila! Look at that. The number of sides along our cylinder have been completely smoothed out. It's starting to look beautiful, but we're retaining some of these hard edges down in here. This transition between this plane and this plane is now a little bit more defined since we've added those new edges. So the SubD engine is really powerful, but if we're trying to create hard edges, we need to make sure we go in and we add edge loops above and below the original edge. So here's the original edge. I have one above and one below. We have to have one edge immediately above and immediately below to ensure that we're establishing that nice transition between those two faces. Here's the original edge on this bottom corner, and we have an edge loop that runs above it and an edge loop that runs below it. And these are loops of edges, so they need to go all the way around your polygon, okay? Or, excuse me, all the way around your mesh. They can't stop halfway. They need to wrap back unto themselves. That defines what a loop is. It's a row of polygons or edges that wraps all the way around the mesh and connects back onto itself. So remember the principle. We have to have a new edge above and below above and below our original edge to create that nice transition. Where we have a lot of edges that are close to one another, we're going to create very sharp pinching or corners. So keep that in mind as you're beginning to explore the power of SubD surfaces when creating hard surface models.